Hello everyone, my name is Naina and I am from the Buddhi Academy. So today we'll continue with the chapter that is structure of atom from standard 11th. So in our last video we have seen about the subatomic particles. So what are the subatomic particles? Those are electrons, protons and neutrons. In that video we have also seen the discovery of electrons, how electrons were discovered. Now, in today's class, we'll see about the charge to mass ratio of electron, charge on electron, and the discovery of protons and neutrons. We'll even see about one of the atomic models, that is Thomson's model of atom. So let's continue with the video. So, discovery of electron, we have also seen the cathode ray discharge tube. So this is the cathode ray discharge tube where cathode rays are passed, and we have discovered the cathode particles which were later named as electrons. We have also seen the results of the cathode ray discharge tube experiment. Now today we'll see the charge to mass ratio of the electron. Now a British physicist J.J. Thomson measured the ratio of electron charge, ratio of electrical charge, that is E, to the mass of electron, that is Me. So electrical charge we represent it as E and mass of electrons we represent it as Me. M to the base E by using cathode ray tube and applying electrical and magnetic fields perpendicular to each other. Now how he carried out or how he found the charge to mass ratio? He found out by using the cathode ray tube only, but he had applied an external electrical and magnetic field perpendicular to each other as well as to the path of electron. Now what he meant is, this is the instrument that he had used, a tube where cathode and anode rays are there. So this part is the cathode ray tube. To that he had attached one more section where this is the path of electron, where electrons are moving. In this path, he had applied an external electrical and magnetic field. So this is the electric poles and this is the magnet. So he applied an electrical and magnetic force perpendicular to each other. So it is somewhat like this. So this is the electrical fields. We can draw it like this. So this is an electrical field. This is the magnetic field, and through this is the path of electron. So each one of them are perpendicular to each other. So this is electric, magnetic and path of electron. Each of them are perpendicular to each other. Now, what Thomson did is, Thomson argued that the amount of deviation of the particles from their path in the presence of electric or magnetic field depends upon. Now what he said, when the electric and magnetic fields are applied, it was observed that the path of electron, it starts to deviate. Deviate means, I'll tell you what exactly happens. Now what he argued is, the magnitude of negative charge on the particle, greater the magnitude of charge on the particle, greater is the interaction with the electric or magnetic field, and thus greater is the deflection. Now when the cathode rays are passed, if there is no electric or magnetic field, it will directly go and attach the center part. It will be a straight line. If there is no electric or magnetic field, no electric or magnetic field. So when there is no electric or magnetic field, the line will be a straight line. But as you apply an electric or magnetic field, Thomson said the greater the charge on the particle. So if the particle has the highest charge, it will deviate. It will either go to A point or it will go to the C point. So the greater the charge, greater is the deflection. So this is the deflection. From straight line, it is deflecting up or it is deflecting down. So this deflection depends on the charge. If the charge is higher, the deflection will be more. Okay. Then what he said, the mass of the particle, lighter the particle, greater the deflection. So what points he said? If the charge is higher, greater the deflection. Similarly, if the particle has light mass or mass of the particle is light, greater the deflection. Thomson argued, he said कि if the charge of the particle, if the charge is carrying, the particle is carrying a higher charge, that means the deflection is also higher. Whereas if the mass of the particle, if it is less, greater the deflection. So high charge and less mass, you will see a great deflection in the movement of particle. Third point, what he said, the strength of the electrical or magnetic field, the deflection of electrons from its original path increases with the increase in the voltage across the electrodes or the strength of the magnetic field. Now, this is the original path of the electrons or the particles. They move in a straight line. If I apply high amount of voltage or the strength of the magnet is high, there you will see the deflection. So even if we increase both these components, strength of both the components, you can see the deflection. A part of this, you can also see the deflection if the particle has higher charge and less mass. Okay. When only electric field is applied, okay, the electrons deviate from the path and hit the cathode ray tube at point A. Now point A is only because of electric charge or electric field. Only of electric field. Whereas C point is because of magnetic field. Okay. Now what are these three fields? When an electrode passes, okay, its original position without any electric or magnetic field, it will go and strike the B point, its original point. But when you apply an electric field, the particles path in which they are moving, this straight line, it will deviate to point A. And when magnetic field is applied, it will deviate to point C. Okay. So this is what Thomson has observed during the experiment. And in this he said कि all these deviations, it occurs because of the charge, mass and the field, electric and magnetic field which was applied. If the charge of the particle is higher, you can see these deflections. And the mass of the particle is light, then also you can see this deflection. And this deflection can also be seen because of this electric or magnetic fields. By carefully balancing the electrical and magnetic field strength, it is possible to bring back the electron to the path followed as in the absence of electric or magnetic field, and they hit the screen at point B. So normally when this point B comes, if there is no electric or magnetic field, this point B will arise. Or if you maintain both this at a same amount, both the electric and magnetic field are balanced, equally balanced, then also you can get this point P. So by carrying out accurate measurements on the amount of deflections observed by the electrons on the electric field strength or magnetic field strength, Thomson was able to determine the value of E by ME. Now, what he did, once he experimented this, once he found the A, B and C points, he measured all these deflections. He measured how much it is going up, how much it is going down. He measured all these distances and he calculated the E by me value, that is electrical charge by mass of electron value, and he found out it to be 1.758820 multiplied by 10 raised to 11 coulombs per kg. Okay, so this was the ratio that he found of electrons, or the ratio of electrical charge upon mass of the electron, that is charge to mass ratio he found, where me is the mass of the electron in kg and E is the magnitude of the charge on the electron in coulombs. Okay, that's why it is coulombs per kg. Since electrons are negatively charged, the charge on the electron is negative E. That's why we write it as E minus, because electrons are considered to have a negative charge. So they are negatively charged. Next is the charge on electron. Now we have found out the electron electrical charge by mass of electron ratio. Now we have to find what is the charge on electron. So R.A. Millikan devised a method known as oil drop method or oil drop experiment to determine the charge on the electrons. So he devised a method known as oil drop experiment. During this experiment, with the help of this experiment, he determined the charge on electrons. He found that the charge on the electron to be minus 16 into 10 raised to minus 19 coulombs. So by this experiment, he found out the charge on electron, that is minus 1.6. The present accepted value of electrical charge is, now this was what he found. Now what we use now is this, that is minus 1.6022 multiplied by 10 raised to minus 19 coulombs. So the mass of the electron was determined by combining this results with Thomson's value of E by me. Now how he found out? By calculating. What he did is he compared these values or used these values in the experiment of J.J. Thomson, where J.J. Thomson has found the E by me ratio. So what he did me equals to E by EME, where this value we know, and we know the value of electrons. Here is the value of electron. By dividing that, mass of electron is 9.19094 multiplied by 10 raised to minus 31 kg. So these calculations we should know. Now we have seen the discovery of electrons. Now along with electrons we have something known as protons and neutrons. Electrons is negatively charged, right? So there should be something with positive charge. Now who discovered this positive charged atoms or the molecules or particles? So electrical discharge carried out in the modified cathode ray tube led to the discovery of particles carrying positive charge. So the cathode ray tube, it not only discovered the electrons, but it discovered another particle which was carrying a positive charge, also known as canal rays. So what this positive charge particles known as? It is known as canal rays, and that one is the cathode rays or cathode particles. These are positively charged particles, and that rays is known as canal rays. So the characteristic of these positively charged particles are, now what are the characteristics of these particles? Unlike cathode rays, the positively charged particles depend upon the nature of gas present in the cathode ray tube. These are simply the positively charged gaseous ions. Now, in cathode ray, what happens? The electrons or the cathode rays, they do not depend on any gases present in the tube, whereas this positively charged particles, they depends on the gas present in the cathode ray tube. So these are simply positively charged gaseous ions. So the charge to mass ratio of particles is found to depend on the gas from which they originate. So whatever gas present in that, from that gas these particles originate. Okay, so the ratio depends on the gas from which they are originated. Some of the positively charged particles carry multiple of the fundamental unit of electrical charges. So some of these positively charged particles, they carry multiple of the fundamental unit of electrical charges. They carry multiple charges. The behavior of these particles in the magnetic or electric field is opposite to that observed from electron or cathode rays. So their behavior now in cathode rays, what happens? They will either go straight or they'll deviate. But this phenomena is not shown by these positively charged particles. They show the opposite of the what electrons or cathode rays show. So the smallest and lightest positive ion was obtained from hydrogen and was called proton. So the smallest and the lightest positive ion was obtained from hydrogen. Hydrogen has only one electrons, right? So it also has one proton. Proton is the positively charged ion. So this positively charged particle was characterized in 1990. Later, a need was felt for the presence of electrically neutral particle. Now we have a positive and a negative. So later it was seen that there is a need to find a neutral particle. So as one of the constituent of atom. So this particle was discovered by Chadwick in 1932. So that neutral particle was later discovered by Chadwick in 1932 by bombarding a thin sheet of beryllium by alpha particles. So what he did, he bombarded or he tried to collide the beryllium molecules with alpha particles. So when electrically neutral particles having a mass slightly greater than that of the protons was emitted, and during this bombarding, during this collision, some of them have during this collision there was a particle which was released, and this particle has a slightly greater mass than the protons, and later this was named as neutrons. Neutrons, why they are named as neutrons? Because they are neutral particles. So now we have electrons, protons and neutrons. So the important properties of these fundamental particles are given in the table. So here we have seen the important properties of the all three of them, that is electrons, protons and neutrons. So electrons symbol is small e, protons small p, neutrons small m. So this is the charge on protons and electrons. So whatever is the charge of electron, the positive of same value is protons. Relative charge +1 -1. Neutrons, they will have a zero value as they are neutral. Mass or the weight of them, their weight will be, this we have calculated, the weight of electron. So this is the weight of proton, and slightly above is the weight of neutron. You can see here 6262 and here it is 493. So slightly greater is the neutrons. Okay. So these are the properties or the fundamental properties of electrons, protons and neutrons. Now next is the atomic models. Now we have seen what electrons, protons and neutrons are. Now where these three are used. Okay. So observations obtained from the experiments mentioned in the previous section have suggested that Dalton's indivisible atom is composed of subatomic particles carrying positive and negative charge. So what above experiments showed what Dalton said ki there is only atom. Atom cannot be further divided. But now we have seen ki atom can further be divided into subatomic particles, right? So it means that Dalton's that indivisible atom that is which cannot be further divided as what Dalton said. That atom is made up of or composed of these subatomic particles. So different atomic models were proposed to explain the distribution of these charged particles. Now we know that atom, it is made up of subatomic particles. But how these subatomic particles are exactly present in an atom? Now there is various atomic models were proposed to explain how these charged particles are distributed in an atom. Although some of these models were not able to explain the stability of atom, two of these models proposed by J.J. Thomson and Ernest Rutherford are discussed below. Now all those theories or models, they were not able to explain the stability of atom, but they have explained this electrons or protons or all these charged particles can be present in such a way, but they forgot about the stability of the atom. Okay, and some of them are discussed below, that is J.J. Thomson's and Ernest Rutherford's. Now today we will see about the Thomson's model of atom. Now what Thomson had did. Okay, so J.J. Thomson in 1899 proposed that an atom possesses a spherical shape, radius approximately 10 raised to minus 10 meters, which is a really small atom. So in which the positively charged is uniformly distributed, the electrons are embedded into it in such a manner as to give the most stable electrostatic arrangement. Now what he said the protons or the positively charged, it is uniformly distributed. So this entire thing, he considered it to be positively charged, and the electrons, what he said, those are embedded or are present inside this positively charged sphere, so that there is a stable electrostatic arrangement. That means there is a stable positive and negative charge arrangement present. So this is what he has mentioned. Now many different names are given to this model. Now to this model where the entire positively charged sphere contains the small electrons embedded or present inside it. To this model there were various names given. For example, plum pudding, raisin pudding or watermelon. Now, this is kind of a watermelon, right, where the entire red part is considered as positively charged and the black seeds were considered to be electrons. Hence, they were named as watermelon. This model can be visualized as a pudding or watermelon of positively charged with plums or seeds, that is electrons. As I said, that red part of watermelon was considered to be the positively charged part or sphere, and the seeds of the watermelon are considered as electrons. Okay. An important feature of this model is that the mass of the atom is assumed to be uniformly distributed over the atom. Now, one important part of this model is it is said that the mass of atom is assumed to be uniform. So whatever the mass of atoms present, any atom, it is uniform in nature or uniformly distributed over the atom. So although this model was able to explain the overall neutrality of the atom but was not consistent with the results of later experiments. Now this model, it was able to explain the stability or the neutrality. It has made the atom neutral because equal number of electrons, protons, everything is neutral, but it was failed to explain it was failed in further experiments where this model was used. So Thomson was awarded Nobel Prize for Physics in 1906 for his theoretical and experimental investigation on the conduction of electricity by gases. Even though this was a failure, but Thomson was awarded a Nobel Prize for Physics because of his theoretical and experimental investigations on the conduction of electricity by gases. Now, in the later half of the 19th century, different kinds of rays were discovered. Okay, now we know that cathode rays, canal rays, but in 19th century, various kinds of rays were discovered besides those mentioned earlier. What I mentioned earlier? Cathode rays and canal rays. So William Roentgen in 1895 showed that when electrons strike a material in the cathode ray tubes, produce rays which can cause fluorescence. I showed that there is a fluorescence here when the ray apply strikes the end part of the tube. There is a fluorescence. So in the fluorescent material placed outside the cathode ray tube, since Roentgen did not know the nature of the radiation, he named them as X-rays. So he doesn't know what that cathode rays which pass, what type of rays they are. So he named them as X-rays, and the name is still carried on, and still we use that names as X-rays. X-rays we still use the name. So it was noticed that X-rays are produced effectively when electrons strike the dense metal anode called targets. These are not deflected by the electric or magnetic fields and have a very high penetrating power through the matter, and that is the reason that these rays are used to study the interior of the objects. Now, the X-rays, it cannot be deviated. Now, cathode rays can be deviated using electrical and magnetic fields, but these X-rays, they are not able to deviate. These are stronger rays which are only moving in a straight line. So even if you apply electrical magnetic field, they won't deviate. Therefore, these are used and they have a high penetrating power. Penetrating power means they can pass through anything. We take X-rays, right? So it can pass through our skin and bones also. So that's why we used to use these X-rays to study the interior of any object. For example, our bones. We use X-rays to scan our bones, right? So these rays are of very short wavelength and possesses electromagnetic character. Okay. So Henry Becquerel observed that there are certain elements which emit radiations on their own and named this phenomena as radioactivity. Now you know that radioactive molecules and all, right? So it was Henry Becquerel who observed that there are certain elements which emit radiations on their own, and he named them as radioactivity, and the elements were named as radioactive elements. This field was developed by Marie Curie, Pierre Curie, and Rutherford and Frederick Soddy. So later these elements were discovered and further studied by all these four scientists. It was observed that there are three kinds of rays, that is alpha, beta and gamma rays are emitted. Okay, Rutherford found the alpha rays consist of high energy particles carrying 2 units of positive charge and 4 units of atomic mass. So Rutherford was the one who found the alpha rays. He concluded that the alpha particles are helium nuclei, as when alpha particle combined with 2 electrons yield helium gas. So what he said was alpha particles are the helium nuclei, because when these alpha particles were combined, he yielded the helium gas. Helium, you know, right? It has the atomic number of 2. So he said ki alpha particles are helium nuclei because 2 alpha particles combinedly give you helium gas. Beta rays are negatively charged particles similar to electrons, and gamma rays have high energy radiations like X-rays, are neutral in nature and do not consist of particles. So as regard penetrating power, alpha are the least, followed by beta and then gamma particles. Okay. Now, in our next video, we will see about the Rutherford's nuclear atom model. So in today's class, we have seen about the Thomson's model. We have also seen the rays, X-rays, alpha rays, beta rays, gamma rays. And then we have also seen about the discovery of protons and neutrons, charge on the electrons, and charge to mass ratio of an electron. So we have seen all this today. That is discovery, charge to mass ratio of electron, charge on electron, discovery of protons and neutrons, and model of J.J. Thomson's model, where he said ki an electron and proton is the entire sphere where electrons are embedded inside. So this is what he said ki J.J. Thomson's model of atom. So thank you for watching my video. Please do like, share and subscribe to our channel.